Good morning, everyone. It's a pleasure to welcome here. First, I would like to introduce myself. I'm Liang Wang from NWPU. My talk today will deal primarily with the task execution quality maximization in mobile crowdsourcing systems. My talk will be in 3 parts, and the content is listed as follows. Now, let's move to the first part of introduction. Generally speaking, one MCS system comprises of a crowd of participants and a platform. The platform outsources many tasks and the recruited participants will move to the locations to perform the task. Actually, one important research problem in MCS system is how to recruit sufficient participants to complete tasks. Now, a novel recruitment strategy, namely WOM-based MCS, emerged. It chose a group of seed users, and seed users will freely enlist their cell neighbors as participants. Its advantages include it can enlarge the crowd users and so on. However, the new strategy faces the following challenges. The first is we need to identify the users during the task propagation process. Second, in addition to the interaction between the platform and the participants, we need to consider the interactions between users. Response to it, we launch our research in this work. Next is the problem and approach. Before formally defining the problem, we would like to introduce several notations such as mobile users, mobile crowdsourcing tasks, and the probability of execution quality. With respect to probability of execution quality, we assume that users who are familiar with task's location and interested in its topic have a great probability to achieve a high quality result. In this work, we devise a MCS-oriented task propagation model. To construct it, we need to rotate from, we need to extenders with a BFS manner, rotate from each seed node. Note that by introducing the expected quality, the users can make local decisions based on the fact that they understand their neighbor on social networks. Users can deliver the task to their neighbors, but neighbors will also make the decision on whether or not to participate in the task. Here we define the task acceptance probability, which uses the probability of execution quantity to indicate it. Now we can formally calculate the overall probability of execution quantity of users on a propagation tree. To fit the beta propagation tree, we adopt multi-level marketing strategy to design the user incentive mechanism that is to offer not only direct but also indirect agents with words. We need to address 2 issues as follows. Here we give the problem definition, namely ETEQM problem. We need to choose a subset of mobile users as seed nodes to recruit participants, such that the expected execution quantity of recruited participants is maximized under the budget constraints. After inference, we propose a cooperative evolutionary based approach, namely ETEQM-CC, to check out problem. The property of our proposed method is illustrated here. In other words, we employ a divide and rule manner. Now let's move to the experimenters and evaluation. We use Foursquare dataset and Goala dataset for experimenters, and the relevant parameters are listed as below. We examine the optimization, effectiveness, and search efficiency of different methods, and the scalability performance of different methods are also examined. And we also inspect the constraint handling strategies. In addition, we examine the effect of propagation distance and threshold. Finally, we conduct a study in campus environment. Finally, it's the conclusion. We propose a new problem, namely ETEQM problem, to recruit participating users on Geo-Social networks and design a propagation model to fit it. Some sorters include the first is, in the future work, we will explore more factors in quantity estimation. The second is skewed distribution or task selection of users. And the third is evaluation with a large-scale user study. Thank you very much.